Hi, this is Ben Brady of the 3D printing section. I thought I'd jump in and do a quick video about how to use Microsoft 3D Builder to create a light socket. Let me reach over here for a balloon lithophane created by LuBan. So you can see right here there's a socket here, a hole in the bottom of this balloon lithophane that will slip over the light socket on a lamp. And then we have some really nice bulbs that will go right up into the socket. So let me just take this out and show you one. Really nice LED bulbs that just go into a lamp socket, and based on the geometry that I've created in Microsoft 3D Builder, we can just slide that bulb right in to the lithophane, and it will light up from inside and show you the picture. So it's a really nice bulb. You can get these on Amazon. I think I paid $15 for 4, and they're really nice bright LEDs. So let's jump into 3D Builder and I'll show you how to do this process. Now, one of the things that I found is with 3D Builder and lithophanes that are created by LuBan. And LuBan is a great product, don't get me wrong, it's a fantastic product. And what it does is phenomenal. But it does create, depending on some settings that you use in LuBan, it does create some pretty huge STL files. So loading and unloading, loading and saving projects can take a considerable amount of time. Now this is an i5 laptop, and even with that, it can take some time loading files created by LuBan. So, and it all has to do with the resolution setting in LuBan that determines the resolution of the photograph that's built into the lithophane. So if you increase the size of the resolution per pixel in LuBan, the STL file gets smaller. But if you use the default, which is 0.1, it makes a pretty substantially sized STL file. So what you want to do is try to balance that, and you want to try to keep the STL under, say, 250 megabytes if you can. I did one last night, getting this whole process down, that the STL was 580 megabytes, which is just huge, and doesn't work well. It takes a long time to, and on my desktop machine behind me, that's an old AMD FX 6300, and if you want to talk about taking forever, that machine takes forever. So we're going to jump in here and get started, and I'll show you how to do this. All right, so the first thing that we have to do is create a new scene in Microsoft 3D Builder. So we're just going to click on here on the new scene button. Excuse me, and that gives us our working surface. And so we're going to go ahead and we're going to say insert. Let me move my controls here. I'm going to say insert, and we're going to add an STL from our list. So we're going to load the object, and I've got an STL file that's stored here on my SD card to make it faster. Now this is going to open the STL, and it's going to take a little while to load. We may have to edit this video a little bit to lessen the amount of loading time. Let's see how quickly it's going to load. This is a lower resolution STL file that I'm using than I used last night, but it could still take some time. I apologize for the racket the birds make. We have animals here, and we live in a small place, so I'm trying to mitigate as much interference as possible. But we have a sulfur-crested cockatoo that just loves to squawk if it hears something outside, and it more than likely Christy is outside working on something on the porch, and the bird hears her, and he doesn't know what the problem is. So that's why you're hearing him screech. So I'm going to go ahead and let this load, and I'll come back once it's loaded and continue on with the video. Okay, now we have our STL file loaded up into the workspace, and the next thing we need to do is let me get rid of some things here out of the way. And so we want to add some components that we're going to use to make our sleeve that goes over the socket on the lamp. So this STL is a balloon lithophane that's created by LuBan, and it allows the images are actually built on the inside of this star. I wanted the outside of the star to be smooth, so I created an interior lithophane. And so the next step is to make a sleeve that will insert into the bottom of the star and allow us to put it on top of the light bulb, so that light will shine from within. So let's get started. We're going to go ahead and we're going to add a cylinder. Now I already have these dimensions memorized, so we don't have to do a whole lot of things. Now, using 3D Builder is not all that intuitive. I mean, it's not the easiest program to learn, but it's easier to do it this way than it is to use Mesh Mixer. Mesh Mixer was a nightmare. I used it for a while, but Autodesk hasn't been enhancing the product or improving the product. The user interface to the product sucks, and so 3D Builder is a step up from Mesh Mixer. But there is some functionality in Mesh Mixer that isn't in 3D Builder. But it would be nice if we did have a little bit more functionality in 3D Builder. One of the things that isn't in 3D Builder is the ability to align objects based on certain dimensions. And so when I just inserted the cylinder, and it put it in line with the STL model, but a lot of the things that we're going to do here, we just have to eyeball it, because there's no way to tell 3D Builder, okay, put this exactly in the center of this other object. So, like I said, I have a bunch of these dimensions memorized. So, for example, we're going to go here to the scale button. I'm going to click on it, and by default, it creates the cylinder 40 by 40 by 40 millimeters. And so I'm going to increase this just a little bit. We're going to say 45 by 45. And we're going to make this 65. And that way we have a tube. We're going to make a tube, and it'll be tall enough to do what we need to do. Now, as you can see, when you scale this object, it scales it on the z-axis on both ends of the z-axis. So rather than keeping it on the workspace represents basically the 3D printer bed. It will expand it in both directions. So what we want to do now is we want to put this back onto the bed. So we're going to go ahead to the object and we're going to say settle. And that's going to raise it up to the workspace. Now it's sitting flat on the bed. The next thing we have to do is we have to move this over to the center of our workspace. So I'm going to pan using the right mouse button. I'm going to pan this over, but I'm going to keep the cylinder selected just so that we can get a little bit better visual representation. So now we're going to click on the move button, and you can see that the object is still highlighted, and there's a little double-headed arrow here. We're going to take that double-headed arrow and we're just going to move it over, and we're going to just eyeball it so that it's just about in the center of. I'm using the grid pattern to judge when we're in the center, and that's pretty much about the center, and so it says 85.33, so I'm just going to call that 85.5 just to be safe, and or actually 80. Let's go 85.4. And that's pretty much in the center. So now, one of the things that's not really intuitive about 3D Builder is the selection of objects. You would think that if you have this object selected as it is now, that if you go here and you click on that, on the STL, that it would deselect this and allow this to be selected, but that's not what happens. When you click on each additional object, for some reason it selects all of them. So we're going to go over here to the deselect button, deselect all button, and now we're going to go ahead and select the star. Now we can move the star up. Now we know that we made the star, the cylinder rather, 65 millimeters tall on the Z. So we have to move this up. So we're going to go ahead and move it up, and so we're going to say, let's move it up to 120 millimeters. Now these calculations are based on the center of the STL. So we're going to move it up a bit. So we're going to say, let's move it up 125, and we'll see where that ends up. And so, as you can see, we've moved it up. Now I'm going to pan with the right mouse button. Now we can't see the edge, and I'm going to go ahead and tilt it a little bit so you can see. There's the bottom of the star right here, and here's the top of the socket. But we're going to go ahead and tilt that down just a little bit. Now you can see from here that the socket is still in the middle of the bottom of the star. So because we only moved it on the x-axis. So now we're going to go ahead and center this view with a Control 0 that will restore the center view. Control 0. It's not, there's hotkeys that are involved in 3D Builder, but they're not intuitive. They don't follow Windows conventions, and you have to get them from a doc that's available on the Microsoft website. So if you click on the help, it brings up this documentation that's just a one-page web page, and it has all the hotkeys listed on it, but they're not intuitive. So at this point now, what we have to do is we have the cylinder, and we position the cylinder, we position the star. Now we have to merge these two elements together. So we go to the Edit menu, and we click on the Merge button. And this is going to take some time, so I'll be back in another minute once it's completed. Okay, the merge has finally stopped. With file sizes like this size STL, it just takes a very long time for the computer to process the millions, literally millions of triangles here in the STL. So what we've done now so far is we created a cylinder and we merged it into the bottom of the STL. Now we have to create a hole in that cylinder so that it will go over the socket. Now, you're going to ask me, I know it's in your mind, Ben, why didn't we create the hole in the cylinder first? Well, the problem is when you merge a cylinder with a hole in it in the bottom of the star, it will merge the outside of the cylinder and the inside of the cylinder with the bottom of the star. And so you'll end up with a cylinder, basically a pipe, being merged into the bottom of the star, but with no hole. So you have to do it the way that we've done it, in the steps that we've done it. First, you have to create a cylinder. You merge the solid cylinder with the bottom of the star, and now we can merge another cylinder that is the diameter of the socket, the light socket that the cylinder is going to go over, and we have to punch a hole through the cylinder that we've already merged, and we'll do that using the subtract feature in Windows 3D Builder. So let's get started on getting the cylinder created. So the first thing we're going to do is we're going to go back here to the Object menu, or actually the Insert menu, and we're going to create another cylinder. And in this case, once again, the cylinder is created 40 by 40 by 40. And so what we want to do is we want to change these dimensions to the diameter of the outside of the light socket, because that's the size hole we need. So this is going to be 32.5. That's the outside diameter. So that's the X, and 32.5, that's the Y. And then we're going to make this long enough to go all the way through the first cylinder. So I'm going to make this 80. And there's a reason that we're going to do that. So now we're going to go back here to the Object, and we're going to say Settle. And that's going to move that up to the work plane. Now, we can do this one or two ways. I typically will do it this way. So we're going to highlight this cylinder again after we complete the settle, and we're going to select that, and then we're going to go to the Rotate function. And 3D Builder uses some strange nomenclature. Rather than just rotate on the X, Y, and Z axis, they use roll, pitch, and yaw. Doesn't make a whole lot of sense. I don't know why they did it like this, but one of the things that is confusing is the use of the nomenclature. Now, roll is going to be rolling on whichever axis is the long way. Pitch is going to be side to side, and yaw is going to be front to back. And you'll see how this works when we do this. But what we want to do is we want to pitch up and down, the ends up and down, because we want to rotate it on the x-axis. So we're going to go ahead and we're going to select pitch, and we're going to say we want it to pitch 90 degrees. So that's 90 degrees there, and that's fine. That's what we want. Next, we want to deselect all, and we want to select the star that has the merged cylinder. And we want to pitch that 90 degrees. Whoops. Why didn't our merge work? That's not good. Control Z twice. And I'm going to do a Control 0 and find out why our merge didn't work. We can let's see if we can recover this, because I don't want to have to wait for another merge. We're going to try something new here. So let's go ahead and select all of this, and we're going to say pitch it 90. And that's going to make everything rotate, like so. Now, then we're going to say deselect all. And then I'm going to move this cylinder. I'm going to go back to move, and I'm going to move it. We're just going to move it down on the Z-axis. And I'm going to rotate using the left mouse button. Wow, look at that. Talk about lucky. It's pretty much in the center. I'm just going to leave it there. I don't think I can do any better than that. So, and now the other thing I'm going to do is I'm going to pull it out just a little bit, so we have something to differentiate our subtract. So we've got that highlighted, and we're going to go to the edit menu, and we're going to say subtract, and that's going to take this cylinder and it's going to subtract it from this cylinder, as well as the bottom of the star. That's why I made it so long. So now you see it didn't take much to do that. I guess because we didn't have the merge, it didn't punch the hole. So we're going to have to redo the merge, and unfortunately, I'll be back. Okay, we've got our merge completed now. I've tested it, and now we'll go ahead and we'll recreate our cylinder. So we're going to go ahead and say cylinder, and we're going to go to the scale, and we're going to say 32, excuse me, 0.5. and we're going to make this 80 to go all the way through. And now we have to go back to the object and tell it to settle. That brings it back up to the workspace on the bottom. And then we'll do just like we did before. We'll go ahead and select both of them. You can see now this bounding box has all of the objects selected. So we're just going to go ahead and go to the rotate, and we're going to rotate. We're going to pitch it 90 degrees. It's going to pull it up like that. Now I'm going to go ahead and say deselect all, and using the left mouse button, I'm going to rotate the view. We're not rotating a model, we're just rotating a view so that we can see what's going on. And then I'm going to go ahead and select this cylinder, and I'm going to move. Let me pull this down. I'm going to move this cylinder down to the center of this other cylinder. So we're going to grab the double-headed handles here, and then using the outline, center it on the other cylinder, and then I'm going to use this double-headed arrow to pull it out just a little bit so we have some designation of what we're going to subtract. And then we're going to go back to edit and hit subtract. And this is going to take a little while. Well, shouldn't be too bad. Hopefully we won't have to stop the video again and wait for it. Well, there it goes, it's done. And now we can rotate the view, and now you can see there's, can we see the inside? No, I guess I didn't create it long enough. So let's go ahead and Control Z, Control Z, Control Z. Now Control Z undoes the things that we do to the actual objects, but it doesn't undo the view. So it's a bit independent. So what we're going to do is I'm going to deselect all and select this object again, and we're going to scale, and I'm going to make it longer. So let's say 100. So that makes it longer still. And then I'm going to go back down here to move, and move this back down using the double-headed arrows. Like so. And unfortunately, there's no way to see inside to see what's going on. So we'll go ahead and go back to the edit and say subtract. And hopefully it's long enough now that we can subtract and see the hole all the way through into the bottom of the star. And I don't see the end of the star. That's the problem. We should be able to see right inside the star. And it's kind of weird that we can't see it. But you get the picture. That's the steps that you use to create. You got to make sure that the outside cylinder is merged with the balloon, and then you punch a hole through it with the new cylinder. That's the diameter of the socket, and then the bulb will go all the way up into the star. So rather than bore you with trying to fix this, that's basically the whole thing. And let's go ahead and rotate this. Now we have to go minus 90 to keep it back up. And then we're going to go ahead and go back to the object and say settle. And that's going to bring it up to the work plane. And that's pretty much it. I'm trying to see if we didn't quite get through the bottom of the star. We can't see inside. That's the problem. So that's basically the process. It does work. That's how I created the hole in this lithophane. You can see I can stick my hand. I can feel the inside of the star. This is exactly how I did this. So we're going to go ahead and let it go for now. And one thing that I will tell you about 3D Builder is there are a couple of color schemes that you can choose in the settings. And what you want is you want the dark theme, because with the light theme, you cannot see these rotational circles that tell you which way the arrows are going to rotate. And it can get pretty confusing because they use such archaic terms as roll, pitch, and yaw. So that's it for now. Thanks for watching. I'm Ben Brady, the 3D Printing Texan.